Okay, so we are doing transformations. We've done this before. You filled in this chart before. Okay? It does not matter what function we're doing things with. If I'm adding and subtracting in parentheses, I'm moving left or right. Okay? It's still inside opposite. If I were to solve for that x-intercept, I would do the opposite operation to move that value out. Right? That's why we do inside opposite. Okay? Anything being added or multiplied outside of my parentheses is going to affect your y value, so that's a vertical transformation. Okay? All of this stuff is still going to apply even though we're doing higher degree polynomials. We've done lines, we've done quadratics, we've done absolute values. Now we're going to do like degrees 3, 4, 5 today. Okay? But the transformation part is not new. We're just giving it a nice little twist for our polynomial section. All right? So let's go up here. Where am I at? All right. So we're going to start with the transformation of x to the power of 3. Okay? This is a new function that we have not worked with yet, but we can very easily do so. Okay? Let's graph the parent function before anything else. Parent function is x to the power of 3, right? Yes, you can plug it in, or we can do some math in math class. I know, crazy. If I plug in 0 into that, my x is 0. What is 0 to the power of 3?
0.
Still 0, so I still have the origin in this function. Okay? Let's go up to 1. If I plug in an x value of 1, I get a y value of what?
3. 1.
Well, what's 1 cubed? 1. Okay? If you plug in 2 for x, what do you get for a y? What's 2 cubed? 8. Not going to fit. It's like up here. Okay? So let's go the other way. How about negative 1? What is negative 1 cubed? Negative 1. What's negative 2 cubed? Negative 8. It's down there. Okay, so we're not going to worry about it. Here we go. This is our parent function, f of x, which is x cubed. Okay? From here, something happened. Okay? The transformation is represented by g of x equals x plus 5 to the power of 3 plus 2. How many transformations happened? 2 of them. I see an x plus 5 in parentheses, and I see a plus 2 on the outside. The exponent does not matter. All we always care about is inside parentheses versus outside parentheses. All right? So x plus 5 in parentheses does what to my function? Left how much? Left 5. What's that plus 2 going to do to my function? It's going to bump everything up 2. So these 3 points that I already plotted are going to move to the left 5 and up 2. Left 5, up 2. Left 5, up 2. Left 5, up 2. And then here's my new one. I did that faster than typing it into Desmos. Okay. Is this familiar? Do you remember doing this? Yeah, it's just new functions that we're working with. Okay. My next one is the one that has a little bit more explaining to do. Okay. You haven't seen something like the next problem. Okay. First of all, we're dealing with x to the power of 4. You've never graphed that, have you? No. X to the power of 4. Well, that's kind of what I did over there. What is, if I plug in 0, what is 0 to the power of 4?
0.
0. Okay. How about 1? What is 1 to the power of 4?
1.
Okay. What's 2 to the power of 4? 16. Up there. Okay. How about negative 1? What's negative 1 to the power of 4?
Negative 1. Oh, wait, no, positive 1.
Positive 1. There we go. What's negative 2 to the power of 4? Up there. Okay. So, it's going to look like a quadratic, but this is when Desmos comes in. I want to show you something. Okay, let me show you the difference. Okay. So x squared is what we're used to, right? There's x squared. Now watch what happens when I make it x to the power of 4. Did you see it? It was very tiny. This to this. It's a little bit more flat. Now watch how I'm going to make it a 6.
Why is it
and 8. Yeah. Okay, it's getting flatter and flatter. Good. No. It's going to look like one. Okay. Like watch.
Wait, is it ever going to get too high to try now?
No. Okay, do you remember doing our multiplicities the other day? Even degrees, they don't cut through the x-axis, they bounce off. Okay, so that's why it's not cutting through. And then the higher your even gets, the more flatter it gets in the middle. Okay, so that is something we had not seen before. So there's my x to the power of 4. So when I graph it, I'm going to make sure I show that it's kind of flat right here. Something like that. That works. All right, this is showing me x squared minus 1 and x squared plus 1. Well, all of my transformations, they don't have x squared in the parentheses, right? It's just x. So again, something new we're looking at. Okay? Because you might think, oh, well, it moves left and it moves right, and that cancels out, so nothing happens. No. It is not true. Okay? So something new is happening. There's an x squared happening inside. Okay? Let's think about what that's going to do to my function. Let's look at Desmos and play with it. Okay? So we have x squared plus 1, and we have x squared minus 1. See what's happening? Okay. So
it's like
our x-intercepts do expand out to -1 and +1. I also have now a y-intercept of -1 instead of 0. Okay? But nothing shifted it down, correct? Let's make our math make sense. With these factors, if I multiply them together, okay, wouldn't the very last number be -1? If I do 1 times -1?
Yeah.
So wouldn't I have a y-intercept of -1? That's where that's coming from. Okay? That'll change, yes. So what's happening here is my factors are transforming my quartic function. Okay? Now, the -1 and the +1 do not come from the two separate factors. It actually comes from just one of them. Okay? Watch what happens. Watch. Watch what happens. Don't we get x-intercepts from solving for x? So if I took, sure. If I took my first factor, x squared minus 1, made it equal to 0. Okay? Because aren't we used to seeing, because shouldn't a power of 4 have 4 solutions?
Yes.
And we only have 2. Okay? So I'm going to add 1 over, and then I'm going to square root. If I square root 1, I get positive and -1. There's my new x-intercepts. Square root. Okay, that's just from my first factor. Okay, so how come I don't have 2 more? Well, look at my second factor. It's x squared plus 1, right? Bless you. If I solve this one, I get x squared equals -1. And what happens when you square root that guy? You get your i's. So there's my 2 other solutions. So there's my 4 solutions, but my graph only shows me the real ones. The imaginaries won't be there. Okay? So having an x squared in my parentheses, it's expanding our x-intercepts. Okay? That's what's pushing them out. So again, this one is very new. It's very unique. Okay? It's very algebra 2. Okay? And then we had our y-intercept of -1. So if you were to FOIL those back out together, you would get a -1 as a y-intercept because it would be your constant on the end. Okay? So this is my new quartic. This is our, that would be our g function. Like that. Okay? So it doesn't follow the traditional transformations in a sense, and that's because of the x squares inside of my parentheses. Okay? Something special for you. You're welcome.
Thanks.
You are so welcome.
Thank
Alright, let's go back to what we're used to. You ready? Yes. Alright, any questions about those two?
No.
Okay. All right, example 2, part A. It's using an x to the 4th again. We good? I can scroll.
Yeah.
Okay, right here. So we have f of x equals x to the 4th, and then they tell me that g of x is negative 1/4 x to the 4th. Okay, so we know what that x to the 4th is going to look like because I just graphed it. It was 1. Careful with your y's, by the way. They're going by 2s. So negative 1, 1, positive 1, positive 1's right there. Okay.
Did you actually? Oh, you don't have DCF.
What's a DC?
Development of early childhood.
Oh, yeah.
I took the test yesterday, and I genuinely didn't know a single thing on there.
Yeah, I heard like if you don't pass it, you get this.
Yeah.
All right. So my g of x has how many transformations going on?
4. Wait. 2.
2. There is a negative that wasn't there before, and I have a 1/4 that was not there before. Those are 2 different transformations. What does the negative do by itself?
The negative means it's negative. Go down. Go.
Okay, I heard flip, which is reflect. Reflect over what?
I'm gonna go.
Over our x-axis. Good.
We
It reflects, so when y'all were saying flip down, you're not wrong, but in Algebra 2, we say reflect over the x-axis.
Yeah.
Okay? That is going to change my x values or my y values? The y values, because we're flipping down. Isn't down a y movement? Okay. What is the 1/4 going to do?
It shrinks it.
Vertically or horizontally? Where are we? We're multiplying by a.
So,
It is a vertical shrink.
This way.
I knew it was shrink.
Right?
And so
It goes smaller.
I'm kind of lost.
Yeah, because the bigger it is, the wider it gets.
But we're doing vertical. So a vertical shrink means my y values are going to be divided by 4, right? Your y values are going to shrink. They're going to get closer together. So this will make my my u wider because we're squishing from top to bottom.
Like a small.
Yes, like a snore. Okay. This is where I want to show you the math and not the Desmos, because I know you know how to type things into Desmos. Okay. I want you to think. Scared. Okay, this original point right here, this lovely.
was 1.
This was negative 1, positive 1, correct?
Oh, yeah.
Okay? I want to do the transformations to it. So if I reflect over the x-axis, you told me that changed which one? The y. So it's not negative 1, positive 1 anymore.
It's negative 1, negative 1.
It's negative 1 now.
Oh, yeah. Oh, yeah.
Okay? So that's this one. Then a vertical shrink by 1/4. Does that change my x value or my y value by 1/4? If it's vertical, my y's. Yes.
Yeah, why? That's why.
My y value gets multiplied by 1/4, which is divided by 4. So now it's not negative 1, negative 1. Now it's negative 1, negative 1/4, or negative 0.25. If you put this new function into Desmos, that's what you're going to see on your table. Okay? I need you to make the math make sense.
Wait.
Okay? So this is now reflected, and then it shrunk closer to the x-axis. This got flipped over and shrunk closer to the x-axis. Did my origin change, by the way?
No, it's still 0.
No, origin is still there. Only thing that'll change your origin is up, down, left, right. And none of that happened.
Wait, is that a B?
Okay?
Yes.
Now, there was a point on here that we were not able to graph originally, right? Remember 2, didn't 2 go to 16? Okay? Watch. Remember, this is like up here somewhere, right? So if I reflect it over the x-axis, where does it go to? 2, negative 16. Good. Then if I vertically shrink it by 1/4, what are my y value gets multiplied by 1/4. So now it's where? 2, negative 4.
I miss Carson.
I can put that there.
Carson, Hoffmeister. I love her so much.
Even Michael's
Carson Hoffmeister.
So look at that. It got flipped over and now it's wider like we thought. Do you have any questions about how to apply the transformations without just typing it into Desmos?
Wait, so how did you get? So we started with that one. What point did we start with? So we started with the blue one over there. This one. So then
And this became this one.
by
that one became that
over the x-axis.
It reflected over the x-axis and then
So
got
turn
one
the other
fourth
one
closer.
negative. And then the vertical strength is what turned it into a negative 1/4?
Yeah.
Okay, that makes more sense.
All right, let's do another one. Let's do another one.
Oh, those are check marks.
Yes.
I said that 2 times.
I thought you said it was a B.
All right, we have a new one. X to the power of 5. X to the power of 5. Let's plug in some values. Start with the origin. Plug in 0. What's 0 to the power of 5?
0.
How about a 1? What's 1 to the power of 5? What's negative 1 to the power of 5?
Negative 1.
Negative 1. Good. Watch out, your Y's are counting by 2s. Okay. What is 2 to the power of 5? More than that.
Wait, what's the question?
2 to the power of 5.
2 to the power of 5
I mean,
is
2 to the power of 5 is 32. Yes. Right there. All right. So this is all it's going to fit.
Where are we getting the points to plug in?
So look, there's an x to the power of 3, right? Watch what happens. 5, 7, 9, 11. What's happening?
The line gets thicker.
Yeah, we're flattening out more in the middle, correct? So it looks like a power of 3, but we have a power of 5 now, so it's a little bit more flat in the middle. A little bit more. Okay? All right. There's my F. All right, so what transformations are going to happen to this function? Let's see, I have a 2x, but it's in parentheses this time. So what is that going to do? 2x inside parentheses.
Here, I can find out.
All right, I'm multiplying by 2 inside. Multiplying by 2 inside is a shrink by a factor of what? 1/2. Remember, inside opposite.
Oh, that makes sense.
Oh, yeah.
How do you know where it's horizontal referential?
Like, come on.
Guys. Okay, I know it's horizontal because it's inside my parentheses attached to my x. And the x is my horizontal transformations. Okay? So this is going to affect my x value by cutting them in half. So my original x's are going to be divided by 2. Okay? I'm getting squished from the sides. They're going to get closer together. Alright? How about this minus 3 right here? It's what? Not really a y-intercept. I mean, it is, but what does it do to everything? Everything brings it down 3, which does make my y-intercept. It will be negative 3 now. Okay? So all of my x's will be divided by 2, and all of my y's will be subtracted by 3. Does that make sense? This is an x. This is a y. So again, I'm going to make my math make sense. Let's start with this point right here. Okay, that was the point -1, -1. Correct? So we're starting with -1, -1. Cut my x in half. What do I get? Negative 0.5, -1. And then drop it down 3. Where does it go? Now it's negative 0.5, -4. my x cut in half, and then my y went down 3.
I thought everything went down.
Okay?
Oh, yeah.
So I have 0.5 and then -4. It got halfway closer to the axis and then dropped down 3 units. All right, let's do my origin. My origin starts at 0, 0. First transformation is I'm cutting my x in half. So what is 0 divided by 2?
0.
Okay, so that didn't change. Now take my y and drop it 3. So where is my new point? 0, -3. Like you told me was going to happen, right? With the y-intercept? All right, how about this lovely? Over here. That was the point 1, 1. First thing I do is I cut my x in half. So what is 1 divided by 2? 0.5. My y did not change. X cut in half. Now I drop my y's down 3. So my y of 1, if I drop it 3, where does it go? -2. Oop, I didn't move it in. So it gets halfway closer and it drops down 3. So now we're here. It's also not the right point. There it is. And here's my new one. So from blue to purple, it got squished from the sides and dropped down. All right, ready to move on? Sure. Do you have questions? Again, I know you can type it into Desmos, guys, but I need you to understand the math. Because what if you didn't have Desmos? It doesn't make it impossible. Okay? Alright. Here, they've already given me the graph. Okay? They want to know what happened to make F turn into G. Okay, so my F up here is the black graph. My G is the blue graph. Okay? It even gives me a hint. So I have F of X is X cubed minus 3X. My G of X, they don't give me a function, but they told me that it took my original and multiplied it by A. So if I look at my transformation list, multiplying by A is something down here.
Vertical stretch.
It's going to be a vertical something. Okay? How do you know it's a vertical stretch?
Because it got taller.
Yes, because it got taller and lower. My Y values got pulled further away from each other. So this was a vertical stretch. Do you know by how much? By 2. Good. What was this Y value? It was -2. What's my new Y value? -4. Isn't that times 2? Y value was 2. Now it's 4. 2 times 2 is 4. So it got multiplied by 2 to get pulled. So that's a stretch and a reflection. That's 2 different things. Negatives are by themselves. Ready for the next one?
Yes.
All right, so my black function is f. That's -1/2 x to the 4th plus 2x squared.
It just got taller.
Okay, it got taller.
Or like it went up.
Good. Plus k means it just got shifted up or down. It went up. It went up how many?
5, 1, 2, 3.
3. Good. Everything got pulled up 3 units. The whole thing slid. We good? We like these, right?
You're so sassy.
Hey, I think you should put that on the test.
I will.
Like where I just tell you up or down.
Sounds great.
That was great.
Moving on.
Remind me of Olivia.
Oh.
So now we're going to write transformed polynomial functions. Okay, and we're going to graph them. So we're adding in what is the new function. Okay, all of these are x to the power of 3 plus x squared plus 1. Okay? We're going to write a rule for G and then graph our new functions for each one. Describe the graph of G as a transformation of the graph of F. All right, so let's graph our original first. Okay? So it was x cubed plus x squared and then plus 1. A little bit, yeah. I'm going to build a table to get some more. There we go. Those are nicer. All right, so I have the points. I'm going to plot these. I don't like how that looks. Let's go back. I like this better. Okay.
Stop.
Okay, here we
It's
go.
actually at 4.
We have -2, -3. So you're graphing these on all 3 of my blank graphs. All 3 of them get this graph. -2, -3. -1, +1. 0, 1. And then 1, 3. They all get this. Get these points.
Wait, what's that?
Okay, 1, 3. All right, -2, -3.
Oh my god, I forgot the next one.
Yep, they are. Watch out, your y's are going by 2. Then it was, what was it? -1, +1. And 0, 1. And then what was it? 2, 3 or 1, 3?
That's what my grandma always says to me. Whenever I get excited, she tells me to hold on to my britches.
All right, so they should all fairly look the same. I'll bring you the points back. Yeah, there's a little bump in between those 2 in the middle. There's a turn. Yes.
I think this is a vowel.
Balance.
I think I got wiggle. Wiggle. I think it's a wiggle.
A little wiggle. Yes, it is a wiggle.
Wiggle.
Wiggle, wiggle.
Hello.
You're welcome. All right, do you have this for all 3?
I didn't need to hear that from you.
Yeah? Okay, so now we're going to transform each one differently. My first one wants me to do what to my function?
All x's are negative.
All my x's are negative. So, literally, in my original equation, I had x cubed plus x squared plus 1, right? But not now, because now all my x's are negative x's. That's what it wants me to do. Okay? So what is negative x cubed? Well, that becomes negative x cubed. How about negative x squared?
Positive x.
Positive x squared. And then my plus 1, is that going to change? No. So here's my new rule.
I like that. Call me Louise.
Okay. Technically, this is also a rule.
No, she's not holding on to her britches very well.
Listen. These are both new rules. These are both showing the transformation. The blue one is simplified. Okay? I think big ideas takes both. I like the blue one the best.
Taste smiling.
Okay? Now, when I go to graph this, I don't have to go to Desmos and type in my new function. What transformations occurred? When I changed all my x's to negative x's, what did I do? I flipped. What did I flip? The x or the y? I flipped the x, which means I'm reflecting over the y-axis. Good. Reflect over y-axis. So all of my x's change their sign. It literally happened in the equation. It's going to literally happen on my graph. This was the point -2, -3, right? Now it's going to be +2, -3. Your x's are changing their signs. Nothing else. This was the point, -1, +1. Now my x is +1. My y is the same. My y-intercept, is it going to change? My x is 0. What's -0? Still 0. All right. This lovely was the point 1, 3. So now I'm going to plot -1, 3. And then, so it reflects nicely over the y-axis. There's my g.
Wait, mine's kind of cute.
And again, Desmos is here
I love when
if you need it. So -x cubed
look, it's
plus x squared plus 1. So I can see it here also. It flips across.
Why did mine
Alright.
cutie patootie.
Ready for the next one?
You are
Alright, part B. It has 3 times f of x. What transformation is happening there? Well, it wants me to take my function and multiply it by 3. So my function was x cubed plus x squared plus 1. It wants me to multiply the entire thing by 3. Okay? So yes, that is a rule. I want my simplified rule, so I'm going to distribute that 3 all the way through. I'm going to get 3x cubed plus 3x squared plus 3. Here's my new rule. What transformation happened when I multiplied everything by 3? A vertical stretch. You good? Your vertical stretch by how much? By 3. Is that going to affect my original x's or my original y's? My y's. Good. All of my y's will get multiplied by 3. Hey, couldn't I say y equals all of this instead of f of x equals all of this?
Yeah.
So if I'm multiplying f of x, I'm multiplying y. Okay, so again, my x's will not change. We're just going to be further down or further up. This was -2, -3. Now I'm at -2, -9, which is down here.
Oh, wait, actually.
Okay, right here. It's going to stay at -1 for my x, but my y value is not a 1 anymore. Now it's a 3. 1 times 3 is 3. My y-intercept, it's not at 1 anymore. Now it's at 3. Doesn't that make sense with my new equation also? That plus 3 on the end?
Yep.
Okay. This lovely point was at 1, +3. The x does not change. My 3 gets multiplied. Like it's multiplied by 3. So what's 3 times 3? 9. It's not that far because this is 4, 6, 8. It's like right here.
I said mine.
I'm being a little dramatic. It's like right there. There we go. So does it look like it got stretched? Alright. Now we have this guy. How many transformations happened this one? There's 2 of them. Okay. So that's my original function, right? What are my x's now? My x's are now 2x, right? We'll do this color. And there should be a -4 after my +1 that's already there. Yes. Okay. So I will say when it comes to big ideas tomorrow, it won't like this. But it would take everything and then on the end have a -3. It would take that. Okay. Our simplified rule, which is my favorite, this becomes 8x cubed plus 4x squared and then -3.
Wait, so I'm gonna text you again because I get some
You would do either one. I would take both. Yep, I would take both. So what happened? Two things happened. What were they? It went down 4. Yep. And, oh, not a stretch. It was a horizontal shrink by 1/2. And it went down 4. So your x's, your x values get divided by 2. They're going to get pushed in. Okay? And then the whole thing is going to drop 4 units. All right? So this was at -2. Now it's going to be at -1. Right? Are you with me? Are you looking?
Oh, yes, sir.
Okay. And my y value, it was -3. If I drop it 4, now we're at -7.
Is that like after the...
Nope, because these go by 2s. Does that make sense what I just did? My first point is -2, -3. The first thing I did was I divided my x value by 2. So that gave me -1, -3. And then I dropped it down 4 units. So it became -1, -7. That's what I'm doing. To all my points. Okay. Here we go. My x value was 1. So now it's going to be a 1/2. Boop. And then instead of a y value of 1, now we're a y value of -3. My x-intercept is 0, 1. My x value is 0. Divide that by 2, it's still 0. Okay. My y value, though, of 1, I divide by, subtract 4. Now it's at -3. Does that make sense of my equation? See the -3 on the end? There it is. All right, my last point. This is the point 1, 3. What is 1 cut in half? 0.5. So we're kind of right here. And then what is 3 minus 3? I'm sorry, what's 3 minus 4? -1. So we definitely got squished, and we got dropped.
Is that all for today?
No, we're gonna do one more. We can do it.
So we're not,
Okay.
oh, it's FSC.
A little bit. All right. Example 5. Let the graph of G be a vertical stretch by a factor of 2, followed by a translation 3 units up of the graph. F of x equals x to the power of 4 minus 2x squared. So, f of x. 2 things are happening to it, correct? Which one did it tell me happened first?
Vertical stretch by factor.
You need to do it in the order they say. There was a vertical stretch of 2, followed by 3 units up. Okay? So we're going to multiply my function by 2, then add 3 to it. Order matters. Order matters. Okay? So my original function here, that didn't change. There we go. Our original function is x to the power of 4 minus 2x squared. So now it is 2x to the 4th minus 4x squared. And then I'm going to do my plus 3. Was there anything for me to combine the 3 with? No, so this one's done. Okay? But like the last one, if there was a 1 there, I would have had to actually put those together. Okay? That's why when it tells you what to do first and then second, it's going to matter. Okay? So yes, this is my new rule for G. Alright, so now we're going to move on to our word problem. It says writing a polynomial model. The function v of x equals 1/3 x cubed minus x squared. This represents the volume in cubic feet of the square pyramid shown. Okay. The function w of x, of v of 3x, represents the volume in cubic feet if my x is being measured in yards instead of feet. Okay. Write a rule for w. Okay, so it wants me to take w right here, we know W of X equals V of 3X. So it wants me to take my original V equation right here, and all of my X's are now going to be 3X. So we're going to have 1/3 3X cubed minus 3X squared. This simplifies to 1/3 27X cubed minus 9X squared. And final simplification, we're going to distribute. So my rule for W is going to be 9x to the power of 3 minus 9x squared. Okay? So again, W is when X is measured in yards is when I'm going to use W. Okay? So this is when X is yards. Is when I would use W. If I'm measuring my pyramid in feet, I would use the V function. So that's the difference between these two. Find and interpret W of 10. Okay? So I have a rule for W. We're going to change the X's to 10. So 9 times 10 cubed minus 9 times 10 squared. That is 9 times 1,000. This is 9,000. That is 9 times 100, so minus 900. So W of 10 equals 8,100. Yep. All right, so the interpret part is the part that y'all struggle with. Ooh, not that. Oh my goodness. The interpret part, there we go. This is what y'all have struggled with recently. So you got to remember what we just did. Like what was the 10? What's the 8,100? Okay. So I'm plugging in 10 into my W function. So my X is now 10, and I only plug it into W when X is measured in yards. So because I put 10 into W, okay. So when I'm gonna type it so it looks better. Okay, so what is this showing me? This is showing me that when X is measured in yards, when X is measured in, let's say when X is measured at 10 yards. That makes it more exact to what we typed in. So when X is measured at 10 yards, that means that the volume of the pyramid is 8,100 feet cubed. Feet cubed. There we go. So when X is measured at 10 yards, the volume of the pyramid is 8,100 feet cubed. That is what interpreting means. I plug X into W, which means my X was measured in yards. That gave me 8,100, which is the volume of my pyramid in feet units. All right, we will practice this tomorrow with some big ideas.